So there have been a few changes. In the beginning, in last video, I was planning to use this rotary switch here, um, which would have two commands, and it would switch on the A between 1 and 6 here, and B1 and B2 to B6. Actually, I opened the rotary switch, and that's not what it is actually. It's actually, it has another contact here. So the way this rotary switch actually works is a bit different. So there's no B, and where's my pen? There's no B, and when one is selected, A, and in this case B1, which would be 7, is connected to A. 7 and 1 are connected to A. When 2 is selected, 8 and 2 are connected to A, and so on. So that's not going to work, right? So I had to come up with another solution. So to use that switch, I had to actually use the ground this pin A, which yeah, that's not what I was going to do in the beginning. So I ground the pin A so that I can use it to change the resistor here, and it's not going to be any B anymore. It's going to be 7, 8, 9, 10, 11, and 12 is going to be open, because this resistor here is going to be setting the highest voltage. And this is what I got here. So I changed the voltages: 3.3, 5, 6, 9, 13.8, which is usually a lead acid battery when it's charged, or trickle charged lead acid battery, and 18 volts, just because I could go higher. The unregulated output was 22.5, something like that. So this is what I got. I'll show you inside in a moment. So I had to use A to ground for this resistor, and what I get in the other side is actually 1, 2, 3, 4, 5, 6 connected to ground as well. So I had to use a way to select the secondary on the transformer with a ground connection. So I had to use 3 relays to do that. And it's basically a logic circuit. So I have 3 relays. This select 0, 1, and 2 would be are the relay coils. So what do I have here? I have a truth table, and Y is the output, and this number here is the number on the input, which will be connected to one of the transformer secondary windings. So 0. Well, I didn't put the number of the secondary winding here, but okay, let's go to that. So 2, it's going to be connected to this one, which is number 2 here. Oh, sorry, not 2, it's 4. 2 doesn't have enough voltage for 3.3 volts, so it's number 4. Next is number 6. Next is number 6, 10, and 8 and 12. Yeah, 8 and 12. Okay, this is actually volts, because the secondary winding is supposed to be 2 volts each, and they are in series to the 6 of them to give us 12 volts. So how does this work? When I select 0, meaning nothing selected, by default the relays are not energized, so by default they are going to be connected to the normally closed circuit. Both of these will select 0, so no relay energized, so this is cut here. So when we select 3.3 volts, this is what's happening. No relay is energized, so 4 volts is going to be going to this point here, this one, yeah, that one as well. So to point A, so that we have around 8 volts here when no relay is energized. So instead of selecting with this switch, I'm selecting these with the relays, and then the common of the first relay is going to be connected to point A. This on the previous, on the other side. So this is going to A, this is going to the transformer. And now, sorry, now let's say I select 1, so relay 1, which is this one. Oh, sorry, this is relay 1, this is relay 3, this is, oh, sorry, this is relay 2, and this is relay, oh, this is relay 1, this is relay 0, and this is 2, yeah, 0, 1, and 2. I'm not going to edit the video, so if you don't like this kind of thing, just let me know. So if I don't select any of the relays, well, I have cell 3, cell 2, cell 1. These are states. These are states, okay? So I am selecting relay 1, relay 2, relay 1 and 2. Ah, this is confusing. Relay 0 is not here. Just made a mistake here. Relay 0. This is 0. This is 1. That was a mistake. 0 and 1. Okay? 1 and 2. Okay. So I can select 4 types of 4 kinds of 4 signals and get them here, depending on how these relays are energized. So if relay 0, if everything is, all the relays are de-energized, number 0 is selected here. If relay 1, if relay 0 is energized, this one means energized, logic level 1, then this input is going to be selected. If relay 1 is energized, this one, it doesn't matter what is in 1 and what is coming in from either of these, so that's an X, because this will select that relay, this relay will select that one. So whatever comes in is dependent on this relay being energized or not. So if relay 1 is energized and relay 2 is not, then number 2 is going to be selected, and if both are energized, then number 3 is going to be selected. It doesn't matter which one is going to be, if this one is energized or not at that moment, because this will be going that way. So this is how we select the secondary coil. So the other thing is, because at a specific point, for example, to select 18 volts, I need to select here number 3 to connect to 12. So for that, I have, when I have the selection type 3 here, I have 2 diodes connected to these so that I don't have to short 1 and 2, the coils together, because otherwise when I, for example, selection 1, if I select 1 and I didn't have these diodes, what happened is that 1 and 2 would be selected whenever I select 1 or 2. So the diodes are there whenever I need to select more than one relay. I need to put these diodes to so that I don't have to short the connect those two coils together. So on selection 1, I just need to energize this relay. These are the kind of the 4 kinds of state on this. Oh, okay. Yeah. Actually, this was right. 2, 1. What I didn't do here is 0. Okay. But I put the ground here. Yeah. This got confusing because this was confusing because I'm putting the states and the relays together. So here nothing is connected, and is relay 0, relay 1, that's right, and here it would be relay 1 and 2, relay 1 and 2, okay? So now it's right. This is the input that is selected is in this blue circle. So that makes it clear, hopefully. So this is a truth table, although this 0, 1, 2, and 3 are the corresponding inputs. Actually, it doesn't matter. It's just like a wire. It doesn't matter if the input is here or there, but it just routes that to from this common point to 0, 1, 2, or 3, depending on these states, and this is how to select the different states. Okay, so let's open this and see what's inside. And for this, I use the LM338 instead of the 317 that we talked about on the last video. And there is a different thing as well, which is I used pots instead of. Okay, let's go through the thing. I can't open it much now, but okay. So instead of having to select the closest resistor to get kind of a closed voltage here, so I used trim pots, 10K trim pots, and for the highest voltages, actually there are series resistors with the trim pot, 1K and 27K, 27K for the 18 volts, 1K for the 13.8. And here on the other circuit, here are the 3 selection wires to select the relay, 2 diodes to select both. So let's actually try to see this. I don't know if you can see that well, but okay. When we select the first one, there's nothing. When we select 3.3 volts, there's nothing. When we select 5 volts, relay number 1 is active. When we select, what is that? Oh, 6 volts. Okay, for 6 volts, relay, yeah, for 6 volts we are selecting the next one. I think that was not enough for for 6 volts into the regulator. So we are selecting the 8 volts secondary, and for 13.8 and 9 actually, for 9 volts we are selecting number 2. Okay, so 3.3 and 5 volts, nothing is selected. 6 volts, number 1, relay number 0, relay 0 is active. Actually selecting the next, which is where is that connected? Yeah, selecting relay number 1, which is connected to 8 volts. Next, for 9 volts, we are selecting relay number 2. Relay number 2, yeah, relay number 2 for 9 volts. Relay number 2 is connected to the 10 volt. And for 13.8 and 18, we are selecting the 12 volt secondary winding. Okay, so that's it about that stuff. Now, what did I do here? So here are the relays, and I had to actually put this board here on the panel to keep this the wires that go through the rotary encoder, rotary switch, as short as possible, because the induction on these the induction that was getting into the feedback circuit of the regulator was a bit weird. It was picking up some of that inductance it was picking up some of the hum, and it was coming out on the output. So here's the LM338. As you can see, there's a fairly small heatsink, and I haven't actually loaded everything, especially the 6 volt setting with 2 amps, but it doesn't hit as much as it would with 40 watts anyway. So then this is smaller. Maybe I need to put a bigger one later. When I can actually load it with 2 amps on every voltage, and I can check that. I actually assembled everything in this board, so it's a bit crowded. So there is the pot to set the 18 volts. And then I have this diode, extra diode, connected to the 8 volt secondary winding, and this capacitor being charged. And what this is for the relays. These are 12 volt relays, and I'm getting power from the 8 volt secondary winding, and it's getting near 15 volts on this capacitor, and I'm powering the relays with that. What else here? I added another 1000 micro capacitor, and here is the unregulated output if I want to use it for something. The bleed resistor. So these diodes, the bleed resistor, and this capacitor were in the power supply, and I reused them. Here are the 2 capacitors that are in the input and the output of the LM338, and that's it for the circuit. So now let's get this on paper so that you can actually see what was done. Oh, by the way, let's just first actually look at the voltages now. Close this thing before something bad happens. Let's get the multimeter. Okay, so 3.31 volts on the first setting, 503, 604, 932. Okay, need to regulate that a bit. 18.12. So it's a matter of setting the trim pots. Yeah, that's quite high there. 9.35, not much different from a new alkaline battery, 9-volt battery. This is a bit high. Yeah. Need to regulate that. No matter. So I don't know if you can hear that, but no relay is being selected. And when I do 6 volts, there's a little click, and another click, and 2 clicks. No difference between these two. Click, another click, another click. So the relays are being selected so that we don't have all that power dissipation. And now let's look at the circuit and what happened. Yeah, let's remove that thing from here. So just to recap, instead of B, it's 7, 8, 9, 10, 11, 12. So I use this resistor to set the 18 volts. Actually, it's a trim pot now. And all these are trim pots. Here I have 27K plus the trim pot. And here I have 1K plus the trim pot. Trim pot, this is a trim pot, and they are all 10K trim pots. So 10K trim. And this 10K. R1 is 1K. And that made it a bit easier. So I only had to, I just stopped worrying about having a 1 milliamp, exact 1 milliamp reference current. So it's higher than that, but that also allows me to have no series resistors here with the 10K trim pot, and then I just had to add it here and there. And what? No, something is wrong here. So this is not it. It's here. And here there's a trim pot. Got it wrong there. And this is not a trim pot. This is a 27K. And this is a 1K here. And this is nothing. So this is just a trim pot. 4 trim pots, 3.3, 5, 6, 9, then 13.8 and 18 volts. Then I have series resistor 1K and what was that? No. So absolutely not. This is 10K plus 33K. It was right. For 9 volts I have 1K here and the pot, and for 13.8 I have 27K and the pot. That's it. 33K in series with the pot, 27K and 1K for the 9 volts. Okay, that is it. Here I added another bulk capacitor here, which is 1000 micro. This is 470. micro bleed resistor is the same, basically it's the same, everything's the same. This is not connected, and this is not connected. Yeah, and this one, so 1 2 3 4, this is connected, sorry, this is connected to, let's see the relays here, 3210, sorry. So this goes to the diode that with a 470 puff micro 470 microfarad capacitor gives us the relay power. Okay, power for the relays from here, and this one is connected to number 2, number 3, number 1, and number 0. Okay, this is how it goes. On the relays here, 0, 1, 2, 3. 0 is 4 volts. 4 volts. 1 is 6 volts. 2 is 10 volts, not 8. It's 10. And 3 is 12. So what I did here as well is that I added a flywheel diode to each of the coils. Okay, so to absorb the inverse peak, and instead of grounding here, I didn't. So this is going to 1. This is going to 0. And this is going to 2. Okay, this 2, 1, and 0. Yeah, 2, 1, and 0. Okay, this is the relay connection. And now these are connected directly to that 470 micro cap relay power here. Permanently connected to this one. So whenever the rotary switch is selecting the volt that well, it's in a specific selection, it goes into this. So let's say selection 3, this is going to be for 18 and 13.8. So 18, 13.8. This one is going to be for 9. This one is going to be for 6. And this one is going to be for 5 and 3.3. Okay, so this is what we have, and that's it for the power supply. This is the 338 T, LM338 T. This is what we have. So let me know if you have any questions, if you want to see this in a more detailed fashion. Maybe if you would like to have a schematic of this thing, maybe even a PCB, because actually the front panel of this thing could be replaced with a PCB, and and could have everything in the PCB. I just don't know how I would handle the rotary switch, but this thing is actually backlight, and yeah, maybe I could actually make a PCB this size with these mounting holes here and put all that stuff mounted on the surface on the other side of the board, and wire the rotary switch down into the PCB. That could be something. But yeah, let me know if you'd like to see that, and see you next time for the next video, which I don't know what it's going to be about. Maybe you can give me some suggestions.